the concept of transformations, which basically you've only done before this year with quadratic functions, right? Transformations of functions, if you had, I know I've reminded you of this before, but if you have your basic y equals x squared parabola that looks nothing like that. Oh, that's so bad. Let's try again. It's actually round on the bottom, but it's not totally round. That's sort of better. The nice thing about this, as opposed to the actual, the old-fashioned whiteboard or blackboard or whatever is, actually it's not going to work because it's going to move the whole axis there. Let's try again to get just this. Oh, come on. Can I get just the blue thing? No. This is wonderful that I'm... oh, come on. There we go. Okay. Now that was worth it. I know that was painful watching, but... because if you're going to do some transformations of this, right? If that's y equals x squared, if I go 1 unit to the right, what's the equation of that? X minus 1 all squared, like with brackets around it. If I move it one the other way? Yeah, if you go one way or the other way, right? Like if I take this and go 1 to the left, I'm doing y equals x plus 1. It goes the opposite, right? Let's undo all that writing I just did. You can just listen instead of writing something right now because I think you remember here. If you were to go up or down, add 1 or subtract 1 after you square the thing. And then the one that was harder was this one, right? Compressing it or expanding it. Okay, compressing, expanding. All of that stuff is transferable to any kind of function. And in fact, later in the year, we're going to do a unit on transformations in general on any function, even if you don't know what its equation is. For now, though, we have the basic function. We have 2 to the x, or 3 to the x, or 5 to the x. So in general, just b to the x. Or we have the logarithm function, log base b of x. So the basic function doesn't look like that. It looks like this if it's an exponential where b is bigger than 1, or this if it's an exponential where b is less than 1, or if you're talking about a logarithm function, this if it's a log function where b is greater than 1, or this if a log function is where b is less than 1. Already we haven't even moved it. And the difficulty level is a lot higher than last year. Why is that? You got all kinds of different basic functions. Grade 11, there was one basic function, y equals x squared. And you got pretty familiar with the points, right? 0, 0, 1, 1, 2, 4, 3, 9, right? Just numbers in their squares. You were familiar with squares for years and years. But suddenly now something, especially this one, somebody's telling you something new, logarithm, and then you have to start doing transformations on those functions. It's tough, okay? So we'll have to try and work with it here. But the good thing is that the concept of the transformations is exactly the same way. If you are able to, if somebody asks you to graph 2x minus 3 up here in the exponent, as long as you can graph 2 to the x, you can graph 2 to the x minus 3. If you know that 2 to the x is going to look like this, and you can get a few points on the graph, then you can get 2 to the x minus 3 just by taking this and moving it down 3. The problem is there's no vertex to deal with like you had for quadratic functions. For quadratic functions, you knew the vertex was at 0, 0. You knew where the new vertex was. Here the problem is it doesn't even go through the origin, right? It doesn't go through that point there. What you probably should think about is there's the asymptote of the thing. All right? There's the asymptote. And just think about where the asymptote goes. If you're transferring this down, transforming it, translating it down, just think, well, that asymptote moves down. If originally it was at 0, now it's going to be at negative 3. If originally this point right here was at 1, it's going to be at negative 2. And then you can just graph it as though you have some points from there, right? Just pretend that this is the new origin and do, well, I got 1 up from there, over 1, up 2, right? Over this 4 is going to be, or fill in all the rest of the points here. 2 is 4, 3 is 8, 4 is 16, 5 is 32. Like do powers of 2, just the way you did with the other ones if you're trying to make the graph of the thing. I just did the wrong transformation, didn't I? What did I do? I went the wrong direction. What should I do here before I totally mislead you? I did it as though it was this, right? Which should I have done there when I did this? I should have gone to the right. I got so busy talking that I did that, right? So this exponent here, if it's in the exponent or if it's not in the exponent, that's the same as if it's in the brackets or out of the brackets with quadratics, right? This was something different than this. And in fact, with this, you didn't even write the bracket. You just said x squared minus 3. It did something different. With logarithm functions, it's even one step more difficult because the function is so new to you here. But the concept is the same. Let's give up on my hopeless drawings and just look at this, right? If you want to shift it one way or the other here, if you're going to shift this up or down, right, there's an exponential function. Just keep track of where the axes are. In grade 11, you actually drew the new set of axes first and then graphed it from there. You can do the same thing with this. If you know it's going to go down 3, just don't even have that graph there and say, okay, I know that it's going to pass through that point, and I know it's going to be down 3 if I'm graphing x squared minus 3. So I just go down and draw the asymptote first, and then put that point on there, and maybe put a vertical axis to help yourself. Okay, draw those, and then just say, well, from there, I know it's up, 0 is 1, 1 is 2, right? I could just put some points on there. 1 is 2, 2 is 4 up from there, 3 is 8, right? I could even put some points over here if I really want to get that one, and I'm kind of approximating here, but that one. And then when you put that graph on there, passes through there, that's hopeless because I'm not even on the right. Oh, it's because I was 1.7, not 2, right? If this was 2, I would be, oh, lovely. If it was 2, it would be pretty close to where I had just drawn my points, right? Okay, so to graph the thing, just locate some of the points. But first put where the asymptote is, and then put this. If you're trying to draw what happens to x plus what 0? Well, it writes it like that because it's just putting in text here. It's saying this is basically log base 2 of x, like plus 0 times 1 doesn't do anything, but that's the way it shows it. In fact, maybe I could show that. Oh, because you know why? Because to graph it in here, you have to graph it a really goofy way. It doesn't. You can't actually put base 2 logarithms in this graphing program. That's why I did that. Now I remember. If you're trying to graph this, okay, let's see if I can hide this thing. Properties. Why will it not let me show that? Okay, well, whatever. If you're trying to graph something log base 2, okay, get rid of this. If we're trying to graph, it's going from bad to worse here. There we go. Okay, we don't have that graph there. Let's say we're trying to graph log base 3, but we're trying to graph it with a shift involved. Okay? Let's say we're shifting this thing 2 to the left. Okay? Go back here for a second. Let's say we're trying to graph y equals log base 3 of x minus plus 2. Let's do that. What does that shift do to the thing? It moves it to the left 2 spots, right? So if you're trying to draw it, just imagine that you have a line right here and do that, okay? I can't draw on this. So actually we could just draw over here. Let's do this. Better plan. That software's not making me very happy right now, so we'll do this. This is a much better idea. Just copy the grid and do the old drawing thing here. Okay, there's a grid. We're going to try and draw this now. If we were going to try and draw y equals log base 3 of x minus 2, you first have to realize the basic function is log base 3. You need to know what that looks like and how to get some of those points. And then you need to know what this do. I know I put plus 2 before. Thank you. Is that what you were going to say? You're on top of it, eh? you think about what the kind of compatible numbers are. But I would first find the right spot, find what that does. It shifts the asymptote. Normally there's the asymptote. That asymptote is going to move to right here, right? Moves 2 to the left, just like everything else. Plus the point that was there moves 2 to the left, right? That 1 value, that's going to be there. That's the first point you should locate on there, is that point. If you want some other points, then just draw them from here. Normally 1 is going to be 0. Think of the values for log base 3 of x. Just think about what are nice numbers. 3, what's the log base 3 of 3? Oh, y. Yeah, I just wrote log base 3 of x. That's what y is. Okay, well, I mean, I could put this over here and then put a y there if you want. You move this over here. Okay, y equals that. Here's y. 3, y is what? 1, right? 0, y was nothing, right? Can it be 0? No, it can't, right? 0, all these things. Can't be that, right? You could do 1 here. What's that? 0. Okay? What would be the next number here I could put in here? 9 is 2. Already I'm going to be off my grid here. 27 is going to be 3. But don't forget, I'm shifting these all 2 to the left. So one way you could do it, if you're more of a visual person, is you can just pretend this is 0 and go from here. So you can just think of these numbers, but then just count from here, right? So if you want 1, 0, there's 1, 0. If you want 3, 1, you can go 3, 1. If you want 9, 2, you can go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can go 2. But first you can move your table because it's in the way. Actually, you can make your table smaller because we don't really need it. If you want, you can. If you're a visual person, you're going to work on the graph and then say 9 is 2. If you're more of a numbers person, what you can say is you can say, this is the table for this. If I have to move that whole thing to the left, all the x values are going to be 2 lower, right? So instead of those values, instead of these, I can just cross them out and say, this is going to go 2 to the left, that's going to go 2 to the left, that's going to go 2 to the left, this one's going to be off my grid, but it would be 25. If you're better working with the numbers and saying, if I did this, it's going to go 2 to the left, I just make those all 2 smaller, whichever one is going to work for you, and then draw the curve in there. Okay? You should know where the asymptote goes. You should know where this intercept goes here. This takes time to get. Okay? At this point, I don't think me talking any longer is going to do you any more good. And in some of you, we already reached that point before. Here's a graph of Mr. B talking and your understanding. Some of you, and it's different for everybody, right? Some of you, without me even saying a word, you already are going to understand some stuff, right? Some of you are going to say, I don't get it, and you need an intro. Most people, it's like maybe the rate that you're understanding, right? I don't know. You're down here somewhere, but maybe me giving you an introduction helps you get started here. But then the more I talk, is it going to keep going like this? Wow, Mr. B, I'm just so fascinated by everything you're saying, and I'm learning so much, and it just keeps going up here. It's more like this. Maybe the first part here, talking more, gets you, but there's kind of a plateau here, right? It's going to level off, and then at some point, I can talk more and more about transforming log functions, all these things. It's not going to get you any higher here. If you want to get beyond that, then you have to, this has to be you doing something, right? If it's, and you doing and making connections and all of that, I'm sure I mentioned this at the beginning of the year. You learn by doing, not by someone telling you. It might help. Some of you are pretty good. You've gotten this far to Math 12 because you're good at learning by having someone talk to you and doing, but it's going to keep going up if you do this part of it. You're doing. You doing. Okay? Because you don't want to have some plateau there. You want to get it above that, right? Asymptote. That's right. It's asymptotic. But you want to then go beyond that, right? You start to do something. It's true, right?